show by the principle of mathematical induction that for all n belonging to the set of natural numbers, 2 raised to the power of 3n minus 1 is divisible by 7. Okay, let us begin. So here we are given a mathematical statement that 2 raised to the power of 3n minus 1 is divisible by 7. So we're going to denote that statement with p of n. So let p of n be the statement. So here we will be considering p of n such that we have 2 raised to the power of 3n minus 1. So this expression is divisible by 7. And we're going to name this statement as statement number 1. Now, our goal will be to verify that this particular statement is true for all n belonging to n. We have to verify that any natural number that we pick, this is always going to be a true statement. So how shall we do that? First, we are going to check if it is true for n equals to 1 or not. N equals to 1 means we are going to check for the first natural number 1. So for n equals to 1, our statement was now going to become p of 1 such that 2 raised to the power of 3 times 1, so that's simply 3, minus 1, we're trying to check if it is divisible by 7 or not. So 2 raised to the power of 3, so that's 8, 8 minus 1, that's 7. Clearly 7 is divisible by 7, that's a fact. Fine. Now, we are going to make an assumption because we have to show that it's true for all natural numbers. So we're going to make an assumption that let n be equals to m. That is, in essence, we are trying to say that p of m is true. P of m is true. The p of m being true, this simply means that p of m, the statement p of m such that 2 raised to the power of 3m minus 1. So this particular expression is also divisible by 7. Right? So let's say this is statement number 2. We're making an assumption that p of m is a true statement, and using the statement we will be showing that if we consider the next consecutive natural number, that means if we choose n equals to m plus 1, then p of m plus 1, which means that 2 raised to the power of 3 multiplied to m plus 1 minus 1. So let's say that this particular expression is also divisible by 7. Now, how do we verify that this is indeed divisible by 7? So for this, we are going to take the help of statement number 2. So from statement number 2, so here we can say that since 2 raised to the power of 3m minus 1 is divisible by 7, what we'll do is we are going to express 2 raised to the power of 3m minus 1 equals to 7 times lambda, where lambda is a natural number. Lambda belongs to the set of natural number. This simply means, this expression simply tells us that 2 raised to the power of 3m minus 1 is divisible by 7. Okay, now let's go back to statement number 3. So statement number 3, this is what we need to show actually. So now 2 raised to the power of 3 raised to the power of m plus 1. So we need to show that this particular statement is divisible by 7. So what we'll do first, we're going to simplify this. So that's going to give us 2 raised to the power of 3m added to 3 minus 1. Right. So we have 2 raised to the power of 3m multiplied to 2 raised to the power of 3 minus 1. So this can be also expressed as 2 raised to the power of 3m times 8 minus 1. Now what we'll do, we're going to subtract 8 from the first term. So we have 2 raised to the power of 3m times 8. We're going to subtract 8 from it. But this is an extra term that we are subtracting. So what we'll do, we're going to add 8 to it as well. And then we have minus 1. This will become evident in a moment why we are taking this extra term. So now from the first term and the second term, if we take 8 as the common factor, so that leaves us with 2 raised to the power of 3m minus 1 added to, now what is 8 minus 1? 8 minus 1, that's simply 7. Now we have already mentioned that 2 raised to the power of 3m minus 1, this can be expressed as 7 times lambda. So we are going to replace it with 7 times lambda added to 7. Now in both of the two terms, we have 7 as the common factor. So that means if we take 7 as the common factor, we have 8 times lambda plus 1. Now lambda already being a natural number, 8 times lambda is going, 8 times lambda plus 1 is going to be another natural number. So we can replace it with, let's call it beta where we are expressing 8 lambda plus 1 in terms of beta. So what we have done is we started out by considering 2 raised to the power of 3 times m plus 1 minus 1, and we are able to express it as 7 times some natural number beta. So here beta belongs to the set of natural number, which means that this simply tells us that 2 raised to the power of this particular expression tells us that 2 raised to the power of 3 times m plus 1 minus 1. So this expression is divisible by, this is divisible by 7. Now if this is divisible by 7, all we have done is we have verified the statement that p of m plus 1, this particular statement is divisible. This is a true statement. So this is a true statement. If this is a true statement, now we can generalize. We can generalize our problem, and we can finally say that the original statement p of n, where we have considered 2 raised to the power of 3 times n minus 1, this expression is divisible by 7 for all values of n, belonging to the set of natural numbers. That means any natural number that we pick, the statement p of n is always going to be a true statement. So by using the principle of mathematical induction, we have successfully verified that the given statement is true for all n belonging to the set of natural numbers n.